Alright, so let's go over scientific notation operations. So anytime you have two numbers like we have here and we are multiplying them, the first step is to account for your exponents. Anytime you multiply something with exponents, all you simply need to do is add your exponents. So you're going to add 5 plus 8. So 5 plus 8 is 13. So we know this is going to end in 10 to the 13th for right now. And then you take your numbers that you have left over, which is the 2 and 2/10 here, and the 3 and 5/10, and you just simply multiply them. So I'm going to do 2 and 2/10 times 3 and 5/10. I switched the order using the commutative property just because I like multiplying by 2 better than 3 and 5. So 2 times 5 is 10, carry the 1, 2 times 3 is 6. Now you get the same thing again, that's why I switched it. And then just add, and I get 660. I have two numbers with decimals, so I got 2 digits behind the decimal in the answer. So I have 6 and 6/10 times 10 to the 13th. So let's try another one. So let's say I start with 5 and 3/10 times 10 to the 12th, and I'm going to multiply that by 6 and 1/10 times 10 to the 10th. Again, because this is multiplication, I'm first going to worry about my exponents. So 10 to the 12th times 10 to the 10th, I'm just going to add those exponents. So I'm going to get 10 to the 22nd. Then I take my numbers I have left over, the 5 and 3/10 and the 6 and 1/10, and I'm going to multiply those numbers. I'm not going to use the commutative property here because it doesn't really matter on this one. So 1 times 3 is 3, 1 times 5 is 5, placeholder, 6 times 3 is 18, and 6 times 5 is 30, plus 1 is 31. So I add that up, I get 3, 3, carry the 1, 32. Sorry, I run out of room there. Alright, I have two numbers behind decimals in the problem, so I got 2 in the answer, so I got 32 and 33/100ths. Now, 32 and 33/100ths is not in scientific notation, so I need to move this decimal so I have a number between 1 and 10 to get it in scientific notation. So I'm moving it 1 to the left, so I get 3 and 233 thousandths. And because I moved that 1 to the left, I need to add 1 to this 22. So I'm going to get 3 and 233 thousandths times 10 to the 23rd. The most you'll ever have to add there is 1. So like my first example, you didn't have to add anything because I still had a number between 1 and 10. But in my second example, I didn't, so I had to move that decimal and add 1 to my exponent. Alright, so let's try some division ones. Alright, so here I have 4 and 2/10 times 10 to the 8 divided by 1 and 2/10 times 10 to the 5th. So here we're dividing, so we're going to do the opposite we did with multiplication. So instead of adding our exponents, we're now going to subtract them. So 8 minus 5 is 3, so I'm going to have times 10 to the 3rd. And then I just take my numbers I have left over, which is the 4 and 2/10 and the 1 and 2/10, and I'm going to divide them. So you're just going to divide this like you would divide any decimal problem. 12 will go into 42 3 times. 3 times 12 is 36. You subtract, you get an 8. Oh, I'm sorry, 6. Add a 0, bring it down. 12 go into 65 times, so I get 3 and 5/10. So my final answer is 3 and 5/10 times 10 to the third. So let's try another one. Alright, so here's another division problem. We have 2 and 5/10 divided and times 10 to the 15th divided by 6 and 25/100 times 10 to the 7th. So again, start with those exponents, and it's division, so we're going to subtract them. So 15 minus 7 is 8, so this is going to end in 10 to the 8th for now. And then we need to take what we have left over, the 2 and 5/10, and divide it by 6 and 25/100. Alright, so I got to move that decimal twice on the outside, twice on the inside. Bring it straight up. Well, 625 won't go into 250. So I have to add another 0. So now I have 2,500 divided by 625, which will go in 4 times. And 4 times 5 is 20, carry the 2. 4 times 2 is 8, plus 2 is 10, carry the 1. 6 times 4 is 24, plus 1 is 25, so it's exactly 2,500. So it goes in 4/10. So now I have 0 and 4/10 times 10 to the 8th. Well, again, this is the same as before. 4/10 isn't between 1 and 10, so I need to move that decimal so I have a number between 1 and 10. So if I move it once to the right, I now have 4, which is between 1 and 10, times 10. And because I moved that decimal to the right, I have to subtract 1 from that exponent, so it's times 10 to the 7th. So my final answer there would be 4 times 10 to the 7th. Alright, so one more example of scientific notation operation. So say the city population is 2 and 25/100 times 10 to the 6th. So that's the population of the city. And 1 out of every 25 people walk to work. And we want to know, well, how many people is that? So we need to find 1/25 of this number. So here we're not going to worry about our exponents first because there's not another exponent to add or subtract it to. So we need to find out what 1/25 of that 2 and 25/100 is. So we need to do 2 and 25/100 times our 1/25. So here I have decimals and I have fractions, so I either need to convert everything to fractions or everything to decimals. So 1/25 is easy enough to convert to a decimal. I would just multiply it by 4 to get 4/100. And 4/100, just as a decimal, would be 4/100. So I'd have 2 and 25/100 times 4/100. So now I got to work that out. So I got 2 and 25/100 times 4/100. So 4 times 5 is 20, carry the 2. 4 times 2 is 8, plus 2 is 10. Carry 1. 4 times 2 is 8, plus 1 is 9. Now I got 1, 2, 3, 4 digits behind the decimal, so I need 4 in my answer. So I'm going to have to add another 0 to get an answer of 9/100. So now I put that back into my original scientific notation. So I have 9/100 times 10 to the 6th people walk to work. Well, that's not in scientific notation, so I need to move that decimal twice. And so since I moved it twice to the right, to get a number between 1 and 10, I'm going to subtract 2 from that exponent. So I end up with, as a final answer, 9 times 10 to the 4th. So out of my population, my original population was, if you work that out in standard form, that'd be 2,250,000. Of that, 9 times 10 to the 4th would work out to 90,000 people. So out of my 2 million people, 90,000 walk to work. So if you wanted standard form, it would be 90,000. If you wanted scientific notation, it would be 9 times 10 to the 4th.